The cerebellum is going to be a section of the brain actually protruding on the posterior side. You can see here, this whole thing is the cerebellum. Now, the cerebellum itself is actually be posterior to both the pons and the medulla, but it's kind of found underneath the actual occipital lobe. So if you're up a little higher in the brain, look at the occipital lobe, that would be more situated right about here. So the occipital lobe would be superior to the cerebellum. Now the cerebellum helps out with precise timing, looks at appropriate patterns of muscle contraction. Well, I was thinking, hold on, what do you mean timing and patterns? Your body, when you do the same actions over and over, have to have the same patterns. For example, if you're walking, would it make a lot of sense to put your left foot forward and then put your left foot forward again? No, it's got to be left foot, right foot, left foot, right foot. And each one of those movements has a set pattern of muscles that controls how those move. So as you do certain activities over and over, you build up this kind of pattern memory. And then your body can replicate that pattern over and over. So look at the anatomy of the cerebellum. So first things first is this thing called the vermis. The vermis is this structure right in the middle. The vermis is kind of where the two halves come together, because we do have a right and left half. So looking at the vermis. Next up is the folia. Now the folia are going to be transversely orientated gyri, which basically means, if you're looking at these lines going across, they're the upfolds. So not the indents, but the parts that are the folds that come out. So a gyri is going to be a fold or an upfold, something that protrudes out. So you have all these little protrusions coming off. So it's not the indents, it's the folds themselves, the upfolds. That's the folia. Now each hemisphere, I mentioned there's two halves. So each hemisphere, the right and left hemispheres, will have three parts or three lobes. We have the anterior lobe, which this is the anterior lobe. You can see it over there and over here. Now, the other lobe just below that is the posterior lobe. You can see from the coloration, this is all posterior lobe. It's all posterior lobe. And then the third lobe, somebody decided to really change things up, is the flocculonodular lobe. Yeah, I couldn't say middle, but anyway, the flocculonodular lobe. It's this little tiny piece right there, and it's right here. That's the flocculonodular lobe. So we have the anterior lobe, the posterior lobe, and the flocculonodular lobe. Again, I have no idea. The arbor vitae. Now think arbor, tree, vitae, life, is kind of refers to the tree of life. It's the white matter you see here. It's branching out like a tree's branches could be. So the arbor vitae is going to be the white matter in the middle of the cerebellum. So that's the white matter that connects backwards out of the cerebellum, that connects all the cerebellum itself. And then we have the cerebellar peduncles. Hopefully remember, we've already talked about all three. We've gone through the superior cerebellar peduncle, we've gone through the middle cerebellar peduncle, and the inferior cerebellar peduncle. Remember that the superior cerebellar peduncle connects the midbrain to the cerebellum. The middle cerebellar peduncle connects the pons to the cerebellum. And the inferior cerebellar peduncle connects the medulla oblongata to the cerebellum. Again, the three connection points allowing information to travel in and out of the cerebellum are going to be the three cerebellar peduncles. So that's the quick overview of the cerebellum. Working our way up into the brain as we move along.